The Grignard reaction is a very common organic reaction to convert a ketone or aldehyde to an alcohol. So is this reaction an oxidation reduction? So stop the video and think about that for just a second. This reaction is a reduction reaction. So note that this ketone has two oxygens bonded to this carbon. The alcohol has only one oxygen, so it's a reduction reaction. Note that it's also a way to make a carbon-carbon bond, very useful in synthesis. In the Grignard reaction, an aldehyde or ketone reacts with the Grignard reagent to form an alcohol, and a carbon-carbon bond forms, so it makes a bigger molecule. So first, the carbon is a nucleophile in the Grignard reagent. Why? So stop the video, answer that question. The carbon-magnesium bond is a polar bond because of electronegativity, and the carbon has a partial negative charge. If it makes it easier for you, think of the Grignard reagent as this type of molecule. So this carbanion reacts at the carbonyl carbon, which is the carbon double bonded to the oxygen, and it forms your product. So stop the video, use those curved arrows to show how the product forms. So the Grignard reaction is an addition reaction. In this case, it's a nucleophilic addition reaction. Note that in this reaction, the carbonyl carbon becomes an alpha carbon. Also note that a new carbon-carbon bond forms on that carbonyl carbon. So in synthesis, this is very valuable because we can make bigger molecules. Here's an example of the Grignard reaction in the synthesis of tamoxifen. So here is where the Grignard reaction occurs. What reaction type occurs in the second step to convert the alcohol to the alkene? So stop the video, think about that for just a second. So that's an elimination reaction. So in the Grignard reaction, you start with an alkyl halide that reacts with magnesium, and that's going to form this Grignard reagent. Then react the Grignard reagent with the aldehyde. Use those curved arrows, write the product of the reaction. More practice, so stop the video, use those curved arrows, predict the product of this reaction. First form the Grignard reagent, then the Grignard reagent reacts with the aldehyde, and then that intermediate reacts with H plus to form the product. Note the new carbon-carbon bond that forms. So let's work backwards. We're going to make a alcohol using the Grignard reaction. So remember, the alpha carbon comes from the carbonyl carbon. Note also there's one extra carbon in our alcohol compared to our starting material. So retrosynthetic analysis is just a fancy word or term for working backwards from the target compound toward the starting materials. So remember to identify those structural features. So this table shows how we can work backwards to make an alcohol using the Grignard reaction. So let's practice. Propose a synthesis of this alcohol using a Grignard reaction. So remember, the alpha carbon comes from the carbonyl carbon. Means we can use this Grignard reagent. The other way to do it is this way. So remember to think of these reactions as skills to develop. So the more you practice, the better you get.